Hi guys, good evening everyone. Good evening guys, how are you all? I hope everyone is doing well. So what we are going to do today is a small topic yet very important. Many of the students they face difficulty in this and they are not able to relate clearly. So yes, we are going to discuss about Van't Hoff factor which helps us to find it out, the abnormal molar mass. Okay, so we'll be discussing about it. But before that, all those new learners who are there on our channel, they must be curious to know about their educator. So let me just quickly introduce myself. So I am Manisha Rani, your chemistry educator at Unacademy, and I have enriched 5 years of experience in both online and offline teaching. I have done my masters from NIT Warangal and bachelor's from Delhi University. I have cracked IIT JAM, CSIR, NET, GATE, all of the prestigious exams, and yes, I have given best ranks through my student, and I'm a plus verified tutor, guys. So yeah, let's just start about the topic without wasting the time. So quickly we'll be learning about it. So first thing that we have to know, that what is abnormal molar mass. Okay, because Van't Hoff factor is a correction factor which helps us to correct the molar mass. Okay, but why this is required, why there is a requirement of correcting the mass, so let's just discuss that. So abnormal molar mass, what it is, so remember guys, we all have learned about colligative property. So when you calculate molar masses from colligative property, then the exact molar mass is not obtained, exact molar masses are not obtained, and this is known as abnormal molar mass. So what we can relate, when molar masses are calculated, when molar masses are calculated by colligative properties, then exact number, exact molar masses are not obtained. You doesn't get the exact value. Exact molar masses are not obtained, and these are known as abnormal molar mass. Okay, now why, what is the reason that we doesn't get the correct molar mass? Because when we used to discuss about the colligative properties, we used to consider a common statement that when a non-volatile solute is added to a volatile solvent, so we used to just think that. But guys, whenever you add a solute to a, yes, whenever you add a solute to a solvent, suppose you have a solvent and in that you are adding a solute. Okay, what you're doing is you're adding a solute. So what is going to happen in that case? So this solute either can associate or it can dissociate. It won't stay just like that, no? So either solute can associate or dissociate. What do you mean by that? Suppose if you have a KCl, like you have taken KCl as a solute. So KCl will dissociate, and if you're taking in water, it will dissociate into K plus and Cl minus ions. It will undergo dissociation. While suppose if you have a acetic acid, CH3COH. So CH3COOH, two molecules, they are going to associate together and they are going to form a dimer. How we'll be discussing that. So basically, what we can relate, that whenever we add a solute to a solvent, so there's two possibilities. At one stage just like that, it can associate as well as dissociate in a solvent, and that's what we have to consider, and that's why we were not getting the correct molar masses from colligative properties, because we didn't consider this aspect. Okay, so what is Van't Hoff factor? What is Van't Hoff factor? So Van't Hoff factor is nothing but because we were getting abnormal molar mass. So what we need to do, we have to get the normal one, we have to get the exact one. How we can get it? With the help of this term. So this Van't Hoff factor can be denoted by I, and how we can define it? So it is a correction factor, because you need to correct the molar masses. So it is a correction factor which is used to It is a correction factor which is used to calculate the exact molar masses of solute. To calculate the exact molar masses of solute. Okay, how you calculate it, guys? Let's just discuss how we can calculate. So we can calculate I once we know the normal molar mass. Like suppose if I say NaCl, we know that its normal molar mass is 23 plus 35.5, but experimentally you are getting different. Okay, so normal molar mass divided by abnormal molar mass. If you will divide, you will get what? You can find it out, the Van't Hoff factor. Another way by which you can calculate I is you can put observed colligative property divided by calculated colligative property. Divided by calculated colligative property. Okay, so by this way also you can calculate. So in any way you can use it, right? Depending upon what things are given, what you can able to interpret from it, you can easily do that. So I can calculate by normal molar mass divided by abnormal molar mass, or I can use observed colligative property divided by, yes, divided by the calculated colligative property. And now next, how you can calculate that? Okay. So what we can relate next, there is one more way by which you can calculate it, which is nothing but you can calculate is number of solute particles. Number of solute particles after association or dissociation divided by number of solute particles before association or dissociation. Before association or dissociation. So this way also you can calculate the value of I, which is Van't Hoff factor. Okay, so what will happen if you will calculate this value? So basically, if you will calculate this value to get the exact molar mass, you can utilize in the different colligative property. So relative lowering of vapor pressure, guys. I hope you guys remember what was the formula for it. So relative lowering of vapor pressure, we used to get the formula was XB is equal to P naught A minus PA divided by P naught A. This was the formula. But you will use the correction factor over here. So when you will use correction factor over here, so from this you will get abnormal molar mass. Right? If you want to get a normal molar mass, what you will do? You will correct it. How? By using the Van't Hoff factor, which is I. So I into XB, P naught A minus PA divided by P naught A. You will get the exact molar mass. Okay, so in relative lowering of vapor pressure we can use, so we on all the colligative properties we have to use this Van't Hoff factor to get the exact molar mass or the normal molar mass, right? Very good. Now if I talk about next, elevation in boiling point, second colligative property, what used to be the formula? Elevation in boiling point, yes. So in elevation in boiling point, what we can relate? It's very simple. The formula was delta TB is equal to KBM. But if I use the Van't Hoff factor, so it will be delta TB is equal to IKBM. So we'll get the corrected value over here. So M here is molality. Delta TB is the change in boiling point. KB is the, yes, molar elevation constant. M is molality. So all those things are there. We know that, right? We already learned the formula. So we have to introduce the Van't Hoff factor over there. Now talking about the third one, depression and freezing point. What you will do, same you will do that. Before, we were having the formula delta TF is equal to I KFM, correct? Like KFM was the formula. Now I'll apply I also, like Van't Hoff factor also here, so that we'll get the correct answer, the correct value. Now what I'll do, I will just introduce the Van't Hoff factor. So you will get a normal molar mass. Now talking about the next fourth one, osmotic pressure. For osmotic pressure, we were having pi is equal to, yes, pi is equal to, like CRT was the formula. But if we'll apply the Van't Hoff factor to get the correct molar mass, I will be using I, which is Van't Hoff factor. It's a correction factor to get the exact molar masses. Okay, it is very simple. I hope everyone is able to relate. Now what this can do, if we got to know about I, okay, it can help us to get the normal molar mass, but there are some more applications of Van't Hoff factor. So let's just discuss that. Okay, so let's just discuss about the applications of Van't Hoff factor. Okay, so if we talk about applications, so in the application, one thing that we can relate is very simple. It can help to find out degree of dissociation. It helps to determine degree of dissociation, means how much a solute is dissociated, how much percentage it has dissociated. You can find it out. So it helps to determine degree of dissociation. Degree of dissociation. Okay, how we can get degree of dissociation? It's very simple. There is a formula small, like alpha. Alpha is a degree of dissociation. How we find it out? I minus 1, I is Van't Hoff factor divided by n minus 1. So what we have to know, what are the terms over here? I is the Van't Hoff factor. Okay, alpha is the degree of dissociation. And what is, yes, what is your N? N is the number of ions produced. Number of ions produced. Like suppose if you have AB, will give you A plus and B minus only. Like suppose if you have MgCl2. So here N will be 2. Like you will get Mg2 plus 2Cl minus. So here N will be 3. Like that. Okay. Remember. And remember guys, here in this case always you will be getting, in case of dissociation, hi Aditya, how are you? So in case of dissociation, what you can relate, always in the case of dissociation, always I is greater than 1. Okay, so in case of dissociation, always I is greater than 1. Okay, and one more thing guys, very important. So always remember, if in the question it is given, yeah, that alpha is, if alpha is given 100%, like if alpha is given is equal to 100%, means 100% dissociation has taken place. So in that case, yes, your I, then I will be becomes equal to N. I'm also good, Amit, like Aditya, I'm also good. So what we are doing right now is we are talking about Van't Hoff factor, what's its applications and how we can utilize it. So it's a small topic but yet very important. Many of the students, they face difficulty in it whenever they get exposed to question related to it. Okay, so we are discussing first quickly the theory part about it, because we should know that how we are going to utilize what is there in it, and then we are going to discuss even the numericals related to it. So yeah, first application, what we understood, that it can help us to find out the degree of dissociation. A Van't Hoff factor can help us to find out the degree of dissociation, which is alpha. How we calculated? I minus n divided by n minus 1. So I is nothing but Van't Hoff factor, n alpha is degree of dissociation. We know that n is number of ions produced. Like for MgCl2 it is 3, like for NaCl it is 2, Na plus plus Cl minus it is 2. So depending upon how many ions it is going to produce. And remember, in case of dissociation, always your Van't Hoff factor will be greater than 1. And if your alpha is given 100%, means 100% your solute is dissociated, in that case your I will be equals to n. Okay, like for example, if I'll give you a question, calculate the Van't Hoff factor for K2SO4 when it is 80% dissociated in solution. So they're saying calculate the Van't Hoff factor for K2SO4 when it is 80% dissociated in solution. So 80% they have said. So alpha is a degree of dissociation. It's not percentage rate of dissociation. It's degree of dissociation. So 80% they have given. Yes. It's potassium sulfate, Aditya. So alpha is given 80%. So if I'll remove percent means per 100. So it will be value 0.8. Correct? Because 80 by 100, I will get the value. So I will get 0.8. Now they set K2SO4 solution. So K2SO4 solution, if I'll dissociate into ions, it's a salt. So I will get 2 potassium plus 1 sulfate ion. So total 2 plus 1, 2 potassium and 1 sulfate. So N will be 3. Okay, that's what we have got to know. So I can use the formula and get the I value. So they are saying dissociation. So we know that alpha is equal to I minus 1 divided by N minus 1. So alpha is given 0.8. I is, we have to find it out. N is 3. So because we have find it out, K2SO4 will give you 2 potassium ions and 1 sulfate ion. So N is 3 and I can just utilize that. So 3 minus 1. So you will get what? I minus 1 divided by 2, right? So here you will get 8.8 into 2 is equal to I minus 1. So I will be 1 plus 1.6, correct? Because 0.8 into 2 is 1.6. Here it will go 1. So you will get 2.6. Okay. So whenever you will be calculating, say, potassium sulfate related any question in which you are using like potassium sulfate and you have to find out colligative property. So to get the exact molar mass, you should multiply it with the 0.2, like 2.6. Okay. So remember that. Next also you can find it out one more application, that you can find it out the degree of association. Second application is degree of association also can be find it out. Degree of association. So how we can find it out? Alpha, even alpha we consider degree of dissociation, association we consider both for the same, like same thing we use, degree of association or dissociation. If you want to distinguish, you can write A in the subscript for alpha, and here for dissociation you can write D in the subscript for alpha. So you will get to remember, like alpha, if D is written in the subscript, so it is a dissociation. If it is written A, so it's degree of association. How you calculated? The formula is 1 minus I divided by 1 minus 1 upon N. Okay, what is that? 1 minus I divided by 1 minus 1 upon N. Terms are same only. I is Van't Hoff factor, N is the number of molecules associated. Okay, number of molecules associated. Remember that. So what we can relate here, it's very simple, guys. N here is number of molecules associated. And in this case, always I will be less than 1. Here, you'll be always getting I always less than 1. In the degree of dissociation case, I we're getting always greater than 1. While here it will be always less than 1. Okay, like I can give you few things that if 100% degree of association is there, if 100% degree of association is given, that a substance is 100% associated, it has two like molecules, they are combined 100%, it has combined. So you can relate that alpha is equal to 1 minus I. We have a formula 1 minus 1 upon n. So 100%, if alpha is 100%, it means value I can get is 100 by 100, right? So 1 is equal to 1 minus I divided by 1 minus 1 upon n. So what you will get? You will get 1 minus 1 upon n is equal to 1 minus I. Okay, so 1 and 1 will get cancelled, and you will get what? I is equal to 1 upon n. So if 100% dissociation will be there, the I will be is equal to 1 upon n. And when 100% dissociation was there, so I was equal to n. How we can relate? It's very simple. You know that 1 will be is equal to I minus 1 divided by n minus 1. So your I minus 1 is equal to n minus 1. Again, you can cancel this off. So I is equal to n if it's a 100% dissociation. Clear with it, everyone? So Aditya, my classes on YouTube are 6:30, right? And on Unacademy app, it is also like the special classes are also at 6:30 p.m. only, and it's like Monday, Wednesday, Friday we have it for 11 standard special classes, and Tuesday, Thursday, Saturday for 12 standard. So yeah, on Unacademy app also it's the same timing, which is 6:30. Whenever we have a YouTube session, so then that time it's not there on Unacademy app. Okay, Aditya? Okay, good. So you should join even there also, because for 12th standard, we have started many of the important questions discussion on these special classes. Okay. Very good. So yeah, let's just talk about the next thing. That the third application for it, the third application of Van't Hoff factor is that you can get degree of dissociation, right? Then what you can relate, you can also find it out dissociation constant. So dissociation constant also. Oh, you okay, Aditya? Yeah. I remember. Correct. You're in 9th and a plus subscriber. So it's for plus subscribers. It is at 4. Correct. It is 4 p.m. to 5 p.m. Aditya. So you must be attending 11 standard sessions, right? More. So 11 classes, it's Tuesday, Thursday, Saturday. And 12th also, if you want to join for any particular topics, it is Monday, Wednesday, Friday at 4 p.m. Very good. So talking about dissociation constant. How you can find it out, the dissociation constant? So with the help of I, you can find it out alpha. And with the help of alpha, you can find it out dissociation constant, which we can write as Ka. So Ka is equal to C alpha square divided by 1 minus alpha. And how you get alpha? Alpha you can get depending upon whether it's association or dissociation, right? You can get on the basis with the help of I. Got it, guys? Yes or no? What is C here? C is concentration. Alpha is degree of dissociation or association. Okay, so that's what you can relate. Very good. So everyone understood? Anyone is having any doubts, guys? You can let me know if you have any doubts. Okay, so let's just discuss 1-2 questions related to it, and you will be able to relate with it, that how we can calculate it. Okay, very good. So there is a very famous question. Okay, so question is 0.6 ml of acetic acid having density 0.6 Yes, guys, just a second. 0.6 ml of acetic acid having density 1.06 gram per ml is dissolved in 1 liter of water. The depression in freezing point observed for this strength of acid was 0.0205 degrees Celsius. Calculate the Van't Hoff factor and dissociation constant of acid. And dissociation constant of acid. Okay, so this is what you have to calculate. So how we can do that? So they have given us volume. Okay, so basically, first of all, can I calculate the number of moles of acetic acid? Can I calculate that? So they said 0.6 ml of acetic acid having density this much, which is 1.06. Okay, so I can calculate the mass because volume into density. Density is equal to mass upon volume. So density is given 1.06. Mass I can find it out. Volume is given 0.6. So it is 1.6 gram per ml and this is ml. So ml and ml will get cut. I will get the mass. So mass will be 1.06 into 0.6. Now can I calculate number of moles? Yes, I can calculate number of moles, which will be given mass divided by molar mass. So 1.06 into 0.6 divided by molar mass of CH3COCH, like acetic acid, can be calculated. Yeah, we can calculate it. 12 into 2 plus 1 into 4 plus 16 into 2, because there is 1 carbon, 3 plus 1, 4 hydrogen, so 1 into 4, there are 2 oxygen. So like that you can relate. I have counted, so you will get 60 gram per mole. So number of moles I can get by putting 60 in the molar mass. So this I'm going to calculate. So we can get that simple. So once you have got that, what I can do, I will be getting the number of moles, which will be around 0.0106, and this will be number of moles. So once you got the number of moles, how you will be calculating molality? Molality is very simple. It is the number of moles of solute dissolved in 1 kg of solvent. So you have to find it out the mass. So moles I have got it, but you know that it is dissolved in water. So water dense mass and volume is same because density of water. Yes, this is a question from the NCERT textbook only. Like this is a very famous question. It's asked in ICSE board like exams also, in CBSE also. So it's an example from a NCERT textbook. Even in your ISC books it is there. So it's very important. Both the exams it is asked. Okay, so molality will be 0.0106 divided by 1000 gram, because 1 liter, if you consider the volume of water they have given in the question. So 1 liter of water, you can consider solvent mass as 1 liter. So 1 liter into 1, like you will get the 1000 gram, because density of water is 1 gram per centimeter cube. So you will get the molality. Once you will get the molality, because you will just divide it, so you will get 0.0106 mole per kg. Okay, so this you got molality. So can I calculate the Van't Hoff factor? Yeah, so it's very simple. So first of all, the Kf for the water, you can remember that the Kf for the water is 1.86. It will be given to you also in the question, and if it is not given, you can remember also. So I can calculate that delta Tf by myself also, that it will be Kf dot m. So Kf is 1.86 and molality we have find it out, which is back 0.0106. Okay, so I will get the delta Tf. Delta Tf, how much I'll be getting it? Around 0.0. You can just solve that, 0.0197. Okay, so basically what I did in the question, they gave you all the values. So with the help of volume and density, I got the mass, because they have given freezing point to me, right? that the depression freezing point observed was this much. So this is observed. So I can do the calculated one. I calculated this. Now how I can find it out? I is observed freezing point divided by calculated freezing point, because observed colligative property divided by, okay, no problem Aditya, you can later on watch it. Okay, and if if you have not studied the colligative properties, maybe you will be facing difficulty also. No problem, later on you can check the colligative properties uh, videos as well, and then you'll be able to relate that. Hi Piyush. So yeah, I we can get as observed freezing point divided by calculated freezing point. So observed is given to me, which is 0.0205. In the question it is given, right? Here itself, 0.0205. I have calculated that, which is 0.0197, like that. Yes. So 0.0197, and I will get the I value, which is 1.041. So it's very simple. If you have got the I value, you can just specifically calculate the degree of, because what they said you have to calculate the Van't Hoff factor. I have calculated that I. Now calculate dissociation constant of acid. Piyush, without studying 85%, how to score? So it's really difficult. Maybe you're asking that till now you have not studied, but if you have not studied in your, say, 12th standard, you are in 12th standard, Piyush, but right now, say you are like, November is about to end, so December, January, February, if 3 months you can go through and you're going to revise it thoroughly, you can easily score 85%. So what you have to do, like whatever textbook you're following, you have to make sure that you are solving all the questions from it, and also you are yes, doing the previous year questions. You are in 10th standard. 10th standard, it's so easy, Piyush, no need to worry. You have a very Aditya is saying, without studying, if you want 85%, you just give money to you're following Selena publication. Oh yeah, so Selena publication, ISC board you're following. So 10th standard, it's not that difficult, right? No, Aditya is just joking with you, Piyush, not like that. It's not going to be there. Okay, so no need to worry, you don't have to feel like any kind of this thing, right? So you have to just know that with now you have still time, and you can, okay, you can go through it. You have still the time, you can follow the syllabus, you can watch the videos on our Unacademy platform, and you will be easily able to do it. Okay. Okay, so Aditya and Piyush, no need to have this kind of discussion. It's not going to be there, right? So, Piyush, you can't get score without studying. You have to do some efforts, right? Okay. So, hi Invictus. So, basically, I said that once you get the I value, yes, you can get the alpha value also, which will be, because it's a dissociation, so you will be getting what? Like 1 minus, yes. So, the formula we have learned, no. So, you will be getting very simple. For dissociation, I minus 1 divided by n minus 1, correct? I minus 1 divided by n minus 1. So, I is 1.041 minus 1. Okay, and if we have acetic acid, how it is going to dissociate? It is going to dissociate into 2 ions, CH3CO minus plus H plus. So 2 ions will be there, 2 minus 1. So you'll be solving it, you will get alpha. And how you can get Ka? C alpha square divided by... This is class 12 topic, Invictus. C alpha square divided by 1 minus alpha. So concentration is given only. We have find it out molality. You can just utilize that and do it. So this is a class 12 topic, Invictus. Class 12 solutions unit. From that we are doing Van't Hoff factor. Okay. So this is what we have studied about today. What is Van't Hoff factor? Van't Hoff factor is a correction factor which is used to correct the molar masses which we get from the colligative properties. Okay, so how you can do that? We discussed the complete theory about it. So those who join late, make sure you are watching the whole video and later on the recording, and you will be able to understand the topic. Okay, so yeah, let me just quickly tell guys the way we have classes on YouTube, even same way we have sessions on Unacademy app as well, and there are special classes which are absolutely free, which are on the same time 6:30 to 7:30 p.m. Monday to Saturday it is there, and yes, you guys can join even there as well and learn about the topics. So okay guys, then we'll be meeting next time learning the new topic for the class 11 class 12 standard. Yes, we'll be doing that. And okay, no, Aditya, I'm not taking it seriously. Okay, so okay guys, so we'll be meeting in the next session then. Thank you all of you. I think I'm not taking it seriously, but Piyush took it very seriously, that he's asking that where we can do that. No. Okay. So, okay, guys, then we'll be meeting in the next session. Thank you, all of you. Bye bye. Bye, guys. Thank you, everyone.